Good morning, and welcome to GovCon 7. My name is Saad Abdali, and I'm a forward-deployed engineer here at Palantir Technologies. And this is Palantir 101. So what I'd like to do is, over the course of the next half hour or 45 minutes, to talk to you a little bit about who we are, about what Palantir is and what it does for the organizations that we work with, and to take some time at the end and give you a very quick product demonstration to give you a sense of what it is we're really talking about here. And so before I jump into all that, I'd really like to start this morning by telling you two stories that I think shed a lot of light on the way that we at Palantir think about the problem of analysis in a world of big data. And so the first story is actually a story about the game of chess. Now, most of you are probably aware that in 1997, IBM built a specialized chess supercomputer named Deep Blue, and that this computer went on to defeat Garry Kasparov, who was at the time the #1 ranked player in the world. Now, ever since then, I'm actually sorry to report things have not gotten much better for human beings in this battle. So nowadays, actually, it's very common to see cell phone software, so chess software running on a smartphone, competing and winning in tournament play. So the question of whether a computer, a really powerful computer, is better than a powerful human at chess is actually not that interesting anymore. Not as interesting as it was at the end of the 20th century. But recently, the chess community has started asking a different kind of question. Instead of pitting humans against computers, they've started to ask, what would happen if we allowed humans and computers to play together as a team? What would be the result? What kind of play would we see? And the results were actually very interesting when they did this and put it together. The first result was that the combination of a human player with the aid of a computer was extremely powerful. And maybe this is actually kind of expected, right? So we know that humans are really good at chess. We know that some computers are really, really good at chess. But we also know they're good at chess for different reasons. They have different strengths. And so the computer obviously has a huge tactical advantage, a computational advantage. A computer can calculate the value of tens of thousands of positions every single second. But a human can take a shortcut through those computations sometimes. A human has experience. A human has insight. The human can feel out his opponent in a way that's very hard for a computer to do. And so these strengths are complementary, and maybe we're not so surprised that the combination of a human and a computer can actually defeat the greatest human players and can also defeat the greatest chess supercomputers. But there was a second result here that's actually a little bit harder to explain. Because you might take a look at that first finding and you might say, okay, humans and computers are complementary, they play very well together. And as a result, let me take my single strongest human player and put at his disposal the single strongest chess computer, make them into a team, and they will dominate the tournament. You might think that, and you'd be wrong. Because it turned out that the team that won this tournament was not a particularly powerful player. It was a modestly skilled player. And it was also not particularly powerful hardware or software. It was commercial-grade laptops running freely available open-source chess tools. And so what happened? How did this combination defeat teams that had stronger players and stronger computers? Well, it turned out there's sort of a hidden factor here, something we didn't consider, which is not just the individual strength of the machine, and not just the individual strength of the human, but the interface, the quality of the interface between the two. How easy is it for the human player to ask the questions that he needs to ask? Is it possible for him to focus on the things that he's really good at, the strategic oversight, the guidance, and to rely on the computer for those tactical components? And so this actually aligns very closely with the way that we at Palantir think about the problem of using computers, using the power of modern computing to assist organizations with the analysis of huge amounts of data. Everything we do focuses on reducing that friction, we call it, the friction between the player or the analyst who wants to use a computer to perform a task and the data or the computation that he wants to do with that computer. The second story I want to tell you is about a company you've probably heard of called PayPal. Had to get my clicker working there for a second. Now, at the time that PayPal was getting its start, there were several other companies also getting involved in the online payments industry. And these included some of the financial heavyweights. So Citibank had its online payment system. Western Union had an online payment system. And this also included eBay, the internet giant of its day, which also had its own competing system. But in the end, all of these other competitors went away one by one. They folded. And it was PayPal, the startup, that succeeded where they had failed. It's a little bit hard to explain this. Why was this the case? Well, it turns out that to understand this, we have to understand one really fundamental fact about the business of online payments at that time, which is that it wasn't a business that had as its central challenge the task of moving money from one account to another. Because all the companies I mentioned were able to more or less do that, and to do it well. That's not what differentiated them. It turns out that the single most important challenge was to figure out how you can move money at scale from one place to another without getting fleeced by the Russian mob. It was really a problem of fraud. You had a huge number of transactions, a large volume of data coming in, and a very short amount of time with which you had to clear those transactions. Customers aren't going to wait a week for you to investigate every single payment. So what you need is the ability to quickly decide whether a given transaction or set of transactions is genuine or fraudulent. It's an analysis problem at its root. And so faced with this problem, PayPal and its competitors took two very different approaches. Most of PayPal's competitors took the approach that, okay, the problem that we have is that we have to make too many decisions very quickly. We don't have enough manpower to investigate these all with our human analysts. And so the answer is to offload this as much as possible into something that a computer can do in a way that's consistent, that's repeatable, and fast, right? Something algorithmic. And this approach, it turned out, just wasn't good enough. PayPal was faced with the exact same problem, but they took kind of a different perspective. So they started at the same place. They said, we have a huge amount of decisions to make, huge number of decisions to make over a large amount of data, and we have to do it quickly. But they took the opposite perspective. They said, well, obviously, the answer is to increase the effectiveness of every human analyst, to put the computing power at the service of the human who's still making the ultimate call, who's still doing the analysis, who's still asking the analytical questions. And the focus is that everything we do on the computing side, everything we do is all about empowering that analyst to explore his data faster, to answer questions quickly, to discover the anomalies he needs to discover, and to make those decisions for the business. So eBay saw the writing on the wall. They had an exit strategy from this battle, which was to purchase PayPal for $1.5 billion. And after this happened, the team at PayPal became notorious in Silicon Valley as very, very prolific entrepreneurs. And some of the members of that team went on to found another company you may have heard of called Palantir. Because it turned out that the same exact problem that the fraud team faced at Palantir is applicable across many domains. Think about the world that they lived in. They lived in a world with a huge amount of data coming in at an increasing rate. And they lived in a world where very quickly they had to make good decisions based on fast analysis of that data. And this is applicable across a range of domains. This is true in law enforcement. It's true in the intelligence community. It's true in defense. It's true in public health, if you're tracking the outbreak of a disease. We live in a world with an increasing amount of data and an increasing need to use that data to drive good decisions. And that's what Palantir is all about. So you might be wondering, what exactly is Palantir? What is the software? What do we do? And so if you can leave here today with sort of a one-sentence description of what exactly that is, I would hope that it's the following. Palantir is an infrastructure for analysis. And I'm using the word infrastructure very, very deliberately here, because Palantir is, among other things, not a visualization tool. And it's really, really easy for people to get that wrong in the beginning, because when you first see the system, when you first see the platform, that's what pops out at you. But the thing to remember is that the visualization and the graphical interface, they're just an interface. Like the steering wheel of a car, it's just a way of accessing all the great stuff the engineers have packed under the hood. Moreover, the interface that you see, the one that you'll see in a few minutes when I show you the demo, is just one interface, one way of getting at all that great work we're doing under the hood. So what I'm trying to say is that Palantir is not a closed environment. On the contrary, the platform is designed from the very beginning to be as open and accessible as possible. So what does that mean in practice? In practice, it means that we support open data formats, making it very easy to get your data from whatever form it existed into and out of Palantir as needed. It means that we are designed to be interoperable with existing third-party applications and services that you already use in your enterprise. And it means that we support an open and public API, meaning that it's possible and easy for third parties to create new functionality, new applications within the platform. And this actually functions a lot like applications for a smartphone. And finally, Palantir is not one database to rule them all. The idea here is not to come in and replace all of your existing investments in infrastructure with this new thing that will hopefully work. On the contrary, it's quite the opposite. The idea is to give you a platform that allows you and your analysts to make more and more effective use to leverage all the existing infrastructure that you have in order to explore your data and to answer questions quickly. So you've been hearing me talk a little bit about what it is that Palantir is doing under the hood. And we actually divide that into 4 major areas of functionality, which I'd like to go through with you in a little bit of detail. But they kind of build on each other, so we're going to start at the bottom here and work our way up. Those 4 areas in order are data integration, search and discovery, knowledge management, and collaboration. So let's get into each one of these in a little bit more detail. Data integration is absolutely the foundation of everything else that Palantir does. And by data integration, we simply mean that Palantir takes all the forms of data that exist across your enterprise, everything from the documents and spreadsheets that live on your analysts' desktops, all the way up to your large enterprise-grade databases, and makes all of those accessible from within a single, unified environment. Now, that one simple idea actually contains within it the kernel of a vast portion of the value that Palantir provides, because we've designed a technique and a framework and software for doing this that is fast, by which I mean that we can come in and have it up and running in days or weeks. It's not a months-long development project. A way that is flexible, meaning that it can deal with all sorts of different data, like I said, from your traditional databases all the way up to far-out stuff, GPS devices, map imagery, video. And a way that is massively scalable. So we're talking about the ability to go up to billions of records, a petabyte of data at some of our larger deployments. The second major area we call search and discovery. So by search, I mean that Palantir provides a single point of access, literally a single search box, that allows you to reach out and touch all of the various data sources in your enterprise. And we're not just talking about simple search. So we're not only talking about searching for what you know, we're also talking about tools to help you discover the things you don't know. So by that I mean we enable advanced conceptual searches, allowing you to search on the basis of the relationships between things, the way a given network might look, as opposed to merely the things themselves. It means the capability to do persistent searches, where I describe to Palantir, these are the basic characteristics of the things that I'm interested in, the things that I want to look at. And Palantir will alert me to the emergence of new data that matches that pattern. And finally, we enable advanced geospatial and temporal searches so that you can understand what was happening or what is happening at a given place and time. Now, we do all this with an eye towards that concept we talked about earlier, with an eye towards reducing the friction between the analyst who has to make use of this big machine to do some task and the computer that he's trying to use, the data that he's trying to get at. So what that means is that we take all this data and make it searchable not just in a way that you're already familiar with, so not in a way that requires the user to be familiar with the underlying data formats and file formats and the various databases from which the data came, but by putting all the data into a model that the analyst actually understands. So I simply mean that you can search directly for people or events. I can directly ask the question, show me all the attacks that took place along this route over the last 3 weeks. I can directly ask the question, show me a heat map of all of the crimes that took place in my district over the last 6 months and how those are different from the previous 6 months. We make asking and answering these questions very easy for a non-technical analyst. Doesn't require somebody to do any programming, and also doesn't require you to do any custom development for each new question that you want to answer. So search is really, really important. The ability to ask these questions and to get answers from your data is important. But by itself, it's not really enough. It's not sufficient. Because I might give you a piece of information. I might tell you, OK, Saad is a Palantir employee. You really need more information to make use of that bit of data. You might want to know, for example, where did this information come from? Who says that Saad works for Palantir? You might want to know, when did we first learn this information? When did the information enter the system? And you might want to know, for example, who's actually allowed to see this? So we might need to separate our data into different compartments. And so Palantir is designed from the beginning with this idea of knowledge management in mind. Every piece of data that enters Palantir is tracked with respect to how and when it entered the system, who's allowed to see it, how the information has changed over time, and to what data sources we attribute this information. And again, all of this is key to doing good analysis, knowing not just what you know, but how and when you knew it, how the information has evolved. So knowledge management is important, which is a way of saying that data and metadata are both important. But again, we're missing one crucial piece of the puzzle here. Because data and metadata are increasingly abundant, and they're increasingly cheap. Cheap to collect, cheap to store. And in most analytical organizations, we find that the most scarce resource is actually something else. The scarcest resource is actually analysis. It's what your analysts produce. It's the application of that human judgment, experience, and insight against the raw information at your disposal. That's the most valuable thing. And so from the beginning, Palantir was designed not just to accommodate the act of analysis, but also to make it easy to share the results of that analysis across the enterprise. The analysis that you produce on top of your data is actually as important or more important than the raw data itself. And so this brings us to the idea of collaboration, allowing individuals and groups of individuals to benefit from each other's work, to work together to build this common picture of reality that analysis implies. This is actually a much trickier concept than I think we first realized when we got into it. Because collaboration has some very contradictory demands that it imposes. On the one hand, the word itself implies that you have some shared picture of the world, right? If you and I are looking at totally different perspectives of reality, if we have totally different data that isn't consonant in some way, then by definition we're not collaborating. We're working totally separately in silos. But on the other hand, individuals and groups need a way to work together and also work separately. They need a way to pursue hypotheses, to test ideas in private. And then finally, once you have these differing views of reality, you need a way to take those and marry them up again and to update your common view of the world. So the way that Palantir approaches this is actually modeled on the way that software engineers work on large software projects, with hundreds of engineers making changes to different pieces of the code base at the same time. And it's a method called version control. And it enables exactly what I just said. It enables you to start as a group with the same view of reality, to make different kinds of changes, test different kinds of hypotheses, and then in the end, to reconcile those changes so that you can update your shared view of the world. And we do all this, of course, in a way that's completely secure, that shows each user exactly those pieces of information that he's allowed to see, no more and no less. So finally, a few notes to end on. Palantir is scalable. As I said, at our largest deployments, we're working with billions of records, up to a petabyte of data, and working on increasing that capacity every single day. Palantir is secure. You've heard me describe how every piece of information, every atom of information that enters the system is tracked with respect to access control. And Palantir is already operating today in some of the most sensitive environments in the world. Palantir is low risk. And by this, what I specifically mean is that Palantir is not a custom development project that you kind of bring us in and we'll talk about the scope for a while, and then 6 to 12 months from now, we might maybe have something to show you. It's the opposite. This is commercial software that's commercially available and can be deployed within weeks. And finally, we're talking about proven technology. Palantir is already being used in all of the domains that I mentioned: tracking diseases in public health, catching bad guys in law enforcement, saving hundreds of millions of dollars in fraud at the big banks. So this is technology that works, technology that's ready now, and we're very excited to get started with you. So what I'd like to do now is switch over and give you a little bit of a sense of what this might look like in practice, sort of a day in the life of a Palantir analyst. And in this case, I'm going to be playing the role of a counterterrorism analyst who's particularly focused on terrorism finance in North Africa. You'll see that I'm tracking some leads in Egypt, and I want to show you sort of from start to finish what my day might look like. So starting from new information coming in from the field, I run that information down and do some investigation, and in the end I have some conclusions that I want to share with the rest of my team and with the rest of the agency. And you'll see what sort of that whole life cycle looks like. So this is what it looks like when I first log into Palantir. And on the left, I've got these things called feeds. So these are simply new incoming documents. In this case, these are new intelligence cables coming in from our sources in the field. And so I'm going to look at my new hit here. And it looks to be a cable from our asset named CT Blue, who's operating at Cairo Station. And it looks like he met an organization and several members of the organization, the Al Muja charity, and he believes these guys are potentially involved in the financing of a terrorism operation, and particularly talking about attacking an iconic symbol in a US city sometime soon. So what I want to do is to take these names, this information that I've gotten, run them down in Palantir, and see if there's anything else we can find that might corroborate this information or give us something else to go on. You'll notice these are the 3 business cards that he captured. And you see some blue highlights. All that means is that another analyst in my shop has already gotten to this document, and he started making it more useful for the rest of us by doing what we call tagging it. And that simply means making it clear that some of these pieces of text are referring to information we have in the system. So this hyperlink actually will lead me to a record, a dossier that we have on this guy, Mike Fikri. And I can add more information to that, so I can say this phone number actually belongs to that guy. I simply tell Palantir that's a phone number. And this is simply a way of making sense of and making use of data that's inherently unstructured, like a written report. So what I'd like to do now is grab these 3 guys, bring them over to my graph, which is sort of the primary link analysis workspace in Palantir, and see what else I can find out about them, how they're related to each other, how they're related to other known entities. You notice that one of them already has a picture, a mugshot, so we definitely have information about this guy. I'm going to double-click on him and open him up. And I want to remind you that what we're kind of looking at here is a combined view of what information we have about Mike Fikri from all of our different data sources. So that might be raw reporting coming in from the field. It might be some of our databases that we have in-house. It might be external data, things like payments and phone calls, as you see over here. So what you're looking at is kind of a summary view of this individual. We can see several versions of his name, a couple of different addresses. His name is rendered in both Latin and Perso-Arabic script, so we can handle all kinds of language data, a couple of different phone numbers. We have different kinds of attachments, so you can attach here video feeds, audio, images. And finally, we have things that he's connected to. So we know that Mike Fikri is connected to at least 23 phone calls and 2 different payments that we've brought into the system. And once we get back to the graph, which is a good place for analyzing networks and relationships, we're going to take another look at that. So I'm going to do that now. What we could do is look at each of these 3 guys in that level of detail, but what I'd like to do is to ask a somewhat broader question. So instead of looking at just the dossier or profile of each of these 3 guys, I'm going to ask a deeper question about how the 3 of them are connected not only to one another, but also how they're embedded in the broader network of information that we have available in Palantir right now. And to do that, we have a great tool called Search Around. So I'm creating a new search. And Palantir is now asking me what kinds of matches, what kinds of connectivity I want to explore. So I can I can look at relationships. I can say, who are these guys related to, and who else are those people related to? I can see where there's matching information in the system. So I can ask Palantir, is there anywhere else where we've seen this same street address? Is there anywhere else we've seen this email or this name show up? And we can also see who they're connected to through events. So who's on the other side of those payments, if we know? Who's on the other side of those phone calls? And who are those people connected to? So Palantir allows me to configure very precisely what kinds of questions I want to ask in this realm. And having configured that one time, I actually don't have to reconfigure it again. So what I'm going to do is use a preset search that I've already created here. And it's going to ask a few different questions. It's asking, what groups are these guys a part of? And who else is a part of those groups? It's asking, what events have they taken part in? And who else is connected to those events? And it's doing all this out to 4 degrees of separation. So it's not stopping at asking the question once, but it's repeatedly asking the question in order to build me a broader network as the result. And you can see that we built out quite a large network here. So I'm going to finish and bring that into my investigation and start taking a look at what we got. So the first thing that I like to do when I get a large result like this is I like Palantir to tell me, at a high level, what am I looking at exactly? So to do that, I'm going to use a tool in Palantir called the histogram. And the histogram will basically give me a summary of whatever it is that I have on my screen here. And so I'm looking at 40 different people on my graph. And it also tells me some of the things they have in common. So it shows me, for example, that 4 of these guys are actually living at the same address in Berkeley, California. And here are the 4 that it highlighted for me. Same thing, 3 of them living at the same address in Vancouver, 3 in Toronto. So it's very easy to see these groups and why they popped up. You can do the same thing with other types of information. So I can see who's living in San Francisco, Berkeley, Daly City. I can see the most common domain for an email address here is hotmail.com. And I can see who's got a Hotmail address, who's got an AOL address. Matches on last name, nationality, and so on. So what's important to note here is not just that Palantir can hold all these different types of information, but that the type of information you want to hold is actually flexible. So in the context of counterterrorism, these are the types of things you'll likely be tracking. You'll be looking at people with their nationalities and biographical information and events like phone calls and payments they've been involved in. But let's think of a totally different context, something like cybersecurity. Well, in that case, you'd configure Palantir so that the objects you're looking at instead of people might be computers and servers. And the events you'd be looking at might be communication, traffic between those computers, right? In the healthcare context, you might be looking at outbreaks of disease and patients rather than terrorists and phone calls, right? So this framework for looking at information is completely flexible and applicable to many different domains. So now that we have a sense of what it is we're looking at, I'd like to take kind of a closer look at what we got here. The first thing I notice is that out of our 3 initial suspects, only one of them really bore any fruit. So the other 2 guys, we don't seem to know very much about them yet. And so for the purposes of right now, I'm going to get rid of them from my screen. Haven't deleted them, just got them out of the way for the moment. And I noticed that Mike Fikri, one of our initial suspects, is connected to this interesting cluster of individuals over here. So when I take a closer look, I see this is labeled a suspected Bay Area cell. So this is a group of individuals that someone else on my team is tracking, and that person has labeled as a potential terrorist cell operating out of the Bay Area. And Mike Fikri is connected to these guys through just 1 degree of separation. So he's connected to someone who is connected to the group. So that automatically raises my interest. That potentially starts to corroborate our suspicion that this guy that our asset met in Cairo might be involved in an attack somewhere in the United States. Now, we also saw that he's connected to this very large and interesting-looking group of individuals over here. So the first thing I want to see is how he's connected. So our original individual, Mike Fikri, is connected to these guys through this sort of unknown entity named MF. And I'm kind of suspicious because they have the same initials, so let's see what else they might have in common. I just open up the connection between these 2 guys, and I can see what it is that they share. So they both list California addresses. They have the same initials, as we already knew. They're both Iranian in nationality. And they both share one of the same phone numbers, exact phone number. So to me, right now, this is not bulletproof. It could mean a lot of different things. But I'd like to test out the hypothesis that these guys are potentially the same person. And so there's a very easy way for me to assert that in Palantir. I can simply take these two guys, right-click on them, and say resolve. I want to assert that these are actually the same individual. And Palantir is going to merge those two guys for me. We're retaining all the original data from both records, retaining all the original information about sourcing. Where did each piece of information come from? When did each piece of information enter the system? We still got all of that, but now we simply have this combined view that incorporates all the addresses, all the phone numbers, all the information from each independent record. Now, a couple of things might happen as a result of this. I might decide later on that we get new information and this original hypothesis was bad. It doesn't make a lot of sense. And at any time, I or another analyst can actually undo what I just did. So I can say unresolve and restore the original data the way it looked before. But something else might happen. I might say, get more information that corroborates this hypothesis. And I might become confident enough that I want to share this hypothesis with the rest of the team, the rest of the organization. And so what I can do is I can take whatever changes I've made to Mike Vickery, and I can say, I want to publish these changes. So far I've been making my changes in an environment that's private to me. But now what I'm doing is saying that anyone who looks up Mike Vickery should see the result of this work. He should see that Mike Vickery and MF are actually the same person. He should see that combined record the way that I see it. And we're done. So let's move on. We've got Mike Vickery now directly connected to this large and interesting group of people. And you see there's a whole lot of different kinds of connectivity going on here. So among this group, you see some payments happening and some phone calls. You see shared addresses and shared flights, so people traveling together. And it's kind of hard to get our head around what's happening here. Who's paying whom? When are these things taking place? And so there's two ways that I want to narrow down this information a little bit further. The first thing that I want to do is take a look at directionality. So if there's a payment going on, somebody is paying someone else, and I want to see that visually. And we have a great tool in Palantir for doing that called flows. So what you're seeing now is a visualization showing you where money is originating and where it's being sent. And the little red dots that you see are actually sized according to the size of the payments. So we can see that there's some smaller stuff going on in the rest of the graph, but really the main action is down here. Large payments going out from this individual to these three groups of people, these three wings. So that's very interesting. And there's two things for you to understand about flows. One is that flows is actually completely extensible. So it's not just a tool for analyzing payments, but it's a tool that allows you to visualize and understand any kind of directional or transactional information. So in this investigation, something else we might look at is, let's say, calls. You might look at what your network looks like in terms of phone activity, right? And you get a different picture of how these guys are connected to each other. But there's a second way in which this is a reflection of the openness of our platform, and that is that flows, which looks and feels very much like it's an integrated piece of the software, is actually written as a plugin. It's written as one of these third-party apps. So it just goes to illustrate the degree to which the software is customizable and can be made to perform different kinds of tasks as needed. All right, so we understand the directionality of these payments now. We see that the guy Mike Vickery is connected to seems to be sending money out to these three different groups. We also want to take a look at time. So we know that money was sent. We know these guys traveled. What was the order in which those things happened? Were all the payments at the same time? Were they right after one after another? Were they before the flights, after the flights? And so we have another tool called the timeline, which will do, I promise, exactly what you think it will do. Show us all the data that we have on our screen in sequence so that we can understand what it is that's happening over time. And so I'm just going to make this a little bit easier for us to understand by coloring the different events. I'm going to take the flights and make them blue, take the payments and make them green. I'm a diehard Verizon customer, so I'm going to make my phone calls red. And now we start to get a little bit clearer picture of what's happening. So we see that the first payment, you have a lot of phone activity, and then the first payment takes place on the 20th of this month. And you have a phone call quickly followed by a money transfer. You see the same pattern repeat itself just one day later with this second payment. And the third payment happens, again, just 2 days after that, again accompanied by a phone call. And if we look shortly afterwards, what happens? We see a lot of flights. So these three groups of people, who, if you recall, they're living in Vancouver, Mexico City, and Toronto, they receive large amounts of money from a guy who's connected to our suspect, accompanied by phone calls. And then the very next day, all 9 of these guys are getting on flights. So where are they going? I'm going to go back to my histogram here and find out what I can about the airports. So I scroll down. You see the 3 original cities, Vancouver, Toronto, and Mexico City. And all 9 of these guys are heading on a flight to Chicago, a US city. So at this point, I'm pretty alarmed. I think I have something interesting. New intelligence came in indicating that a group of people might be involved in plotting an attack on a US city or financing an attack on a US city. We found that that person, one of those 3 people, is connected to someone who's making large payments of money to 3 different groups of individuals who are living outside the US. And immediately afterwards, all 3 groups are traveling to the same US city. So this looks to me like it very well may be a cell activation pattern. These guys are getting ready for some kind of operation. And so what I can do is quickly share my analysis with members of my team, with other agencies, with local law enforcement. And I can do that very quickly. So I'll just take snapshots of a few of the key pieces of evidence here. I'll take a snapshot of this timeline, which shows you the pattern of activity. I'll take a snapshot of my graph. And having done that, I'll head over to export what I've done into a format that's digestible. In this case, build a quick PowerPoint presentation. So what Palantir will do here is take the path that I took through my investigation. So at first I looked at this guy, I built out a network, I explored that network in a little more detail. And of course I might want to change some of this, right? So I might want to explain what exactly this timeline indicates. But essentially now I have something that's almost ready to go. It's almost ready to be shared after I tweak it just a little bit. And so what I just walked you through is sort of the full life cycle of a day in the life of a Palantir analyst, starting with getting new information from the field, doing a little bit of investigation and analysis on that information, making some discoveries that might be important, and then sharing that information with other people. You'll notice what it is that I actually spent my time on. So I spent most of my time talking with you about the actual analytical process, the kinds of questions I wanted to ask about who these guys are and what we know about them. What you didn't see me do was spend a lot of time searching through different databases for these names. You didn't see me spending a lot of time futzing with different kinds of data formats or arcane queries. And you also didn't see me spend a lot of time at the end reproducing all my work in a format that's digestible. I didn't have to spend a lot of time creating a presentation or creating a report about what I did. So what you saw me do was essentially spend time doing the things that, as an analyst, I'm good at. Spending my time applying my domain expertise, applying my intuition, following the leads that I think are interesting, and allowing the computer to take care of the things that it's good at. Searching for data, retrieving large amounts of data, converting data and transmitting it into different formats to make it digestible. So all of this, again, comes down to this idea of reducing the friction between me as an analyst and the information that I'm working with, allowing me to quickly answer questions, to quickly do an investigation, and to quickly share that data, share that analysis across the enterprise. I hope this has been a fairly useful demonstration, a very cursory demonstration, I promise you, of what it is that Palantir does. There's a whole lot that you haven't seen yet. There's a fantastic geospatial capability that we haven't even touched on. There's some amazing things we're doing to work with data at very, very large scale, like I said. And I'm personally very, very excited about the continued growth of our mobile capability, which takes all the power of the Palantir platform that you've seen and makes all of that available in the palm of your hand on your smartphone. I hope that you get a chance today to talk to us, to talk to all of our customers who are using Palantir today. And I hope you have a great day at the conference. Thank you so much for your time.